Good morning, girls. I'm continuing the same exercise 7.1, and the whole exercise, children, is based on congruence. The congruence of triangles we have studied in the beginning of the chapter. Now, coming to question number 4, till 3 I discussed with you yesterday. Coming to question number 4, as you can see that there are two parallel lines, L and M, right? They are intersected by another pair of parallel lines, P and Q. And you can see that the points over here are A, D, C and B. Okay, actually this point A has to be here. So I've drawn the diagram in my diary. I'll show you. You have to prove that triangle ABC is congruent to triangle CDA, right? These two lines, parallel lines, are intersected by another pair of parallel lines, and we have to prove that the two triangles are congruent. Now you can see the diagram here. These are the two parallel lines, L and M. P and Q are also parallel to each other. So obviously when we will prove these two triangles to be congruent, we can say that these two lines are parallel and these are transversals. Or we can say that these are parallel lines and these two L and M are transversal. So vice versa, we can use these properties. So beginning with, I will write number 1, given. What is given in the question? That L is parallel to M and P is parallel to Q. Now as you can see the triangles over here, if I take proof, okay, and what do we have to prove? We have to prove that triangle ABC is congruent to triangle CAD. Now children, when we are solving any question on proofs, we have to write systematically. First we write what is given in the question, second we write what we have to prove, and then we start with the proof. Okay, so we cannot write randomly here and there anything. We will first draw the figure, right? After drawing the figure, whatever points are given in that particular question, you will write those, and after that you will write what do we have to prove in the proper correct serial order, and then we start with the proof. Okay, so over here now we have to prove that triangle ABC is congruent to triangle CAD. So in triangle ABC and triangle CAD, now you know that children, these are parallel lines, right? If these are parallel lines, if I talk about this angle, if I talk about this angle, that is this one, and when I talk about this angle, you can understand that these are alternate interior angles. Now this angle is for triangle ABC and this angle is for triangle CAD, right? So what I want to explain over here, that in the two triangles, triangle ACB is equal to CAD. By which property? By alternate interior angle property, because these are parallel lines and this is a transversal, right? So first point we are going to write is, angle ACB is equal to angle CAD, and the property is alternate interior angles are equal, and we can apply this alternate interior angle property only when the lines are parallel. So obviously over here the lines are parallel and hence we can apply this property. Similarly, coming to the next, when I look at the figure this way, starting from B, A, C, D, like if I go this way, right, this. So if I mark these angles, that is this one and this one. Now these two angles are also alternate interior angles. So therefore we will write second point we write Angle BAC, angle BAC is equal to angle, which one? ACD or DCA, right? We'll write DCA. Again, the alternate interior angles are equal. Then, third part, corresponding equal part, we can see that this is the side, that is the AC side, is common for both the triangles. So hence we are going to write AC is equal to AC, and that is a common side. Now since we have got three corresponding equal parts, children, we will see which congruence we can apply, which rule we can apply. Now we have taken this angle, right? And in between we have the side. Okay, again, this angle and this angle and this angle, this side. Over here also this angle, which is highlighted with the blue pen, then this and side. So the side is included between the two angles. Hence the rule which we can apply over here is, therefore, triangle ABC is congruent to triangle CAD by ASA rule. Okay, so this is what we had to prove, that the two triangles are congruent. You can check. Yes. And after that, yeah, that's all we have to prove, that these two triangles are congruent. And we have used which property, which rule? We have used ASA rule. Okay, so if you have any doubt in this question, children, you can ask me. You can say that these lines are, you will say that these lines are parallel, these are also parallel lines. And when we talk about this angle, we have to see which transversal we are talking about. So when we talk about this angle DAC, this angle is equal to ACB. Why? Because these lines are parallel and the transversal is cutting the two parallel lines, right? Therefore we can apply the alternate interior angle property. So I hope this question is clear to you. Now coming to the next question. Question number 5, you can check your book. This is a diagram given 7.20, which says that this is the bisector L is a bisector of this angle A. So that means we can say that this angle is equal to this angle, right? And BQ and BP are what? They are perpendiculars on the arms on these rays, we can say. We have to show that the two triangles APB and AQB are congruent. Then we also have to say that BP is equal to BQ, or we can say that B is equidistant from the arms of angle A. This we will see later on. So we will come to the first point. In the diagram you can see that these are perpendiculars and L is a bisector. So I have already written over here, given L is the bisector of which angle? Angle A, and BQ and BP are the perpendiculars. Now after this, what I told you, we will write to prove. Now to prove, we write number 1, triangle APB is congruent to triangle AQB. Yes. And the second point which we have to prove is BP is equal to BQ. Now to prove, we take these two triangles, we write the proof. So I told you we will write in the systematic order, given, then to prove, then proof. So therefore we write triangle APB, in triangle APB and triangle AQB, we can say that BPA, angle BPA is equal to angle BQA equals to 90 degree, because the perpendiculars are given. So we write BP and BQ are perpendiculars, right? This is given in the question. Then the second point we are going to take is, because L is a bisector, right? L is a bisector, so therefore BAP, PAB, angle PAB is equal to QAB, QAB, given. And what is given? L is the bisector. Bisector divides the two angles or a line into two equal parts. And number 3, as you can see that AB is a common side, so we write AB is equal to AB and the side is common. Therefore, we write the triangles, what? APB is congruent to triangle AQB. Now, which property? Angle, and side. Okay, angle, side. Now, is it ASA or AS? It cannot be ASA because the side is not included between these two angles. Therefore, the property which will be used over here will be AAS. AAS. So therefore, here I am going to write by AAS rule. Yes. Okay. Now, what did we have to prove the second point as? Therefore, BP is equal to BQ and CPCT, corresponding parts of the congruent triangles, or we can say that B is equidistant. We can also say that B is equidistant from Q and P, or we can say B is equidistant from the arms of angle A, right, which is asked in the question. So therefore, in the end here we write BP is equal to BQ CPCT, or we can write that B is equidistant from the arms of angle A. So this completes your question number 5. Now look at this. Question number 6. Again, congruence. We have to prove that, okay, in the figure 7.21, AC is equal to AE. AB is equal to AD, clearly given. When you'll see this diagram, you will clearly understand. Angle BAD, that this small angle which is shown highlighted here, is equal to angle EAC, which is also, they are equal, they are shown here. And you have to show that BC is equal to DE. Now, to prove that these two sides are equal, children, we are going to first take the two triangles. You concentrate on this figure ABC. Which triangle? ABC. Suppose I forget what is here over in between, there's no line. So you have to only see the triangle ABC, and then you have to see the triangle, which one? This one. No. First, repeat. First we'll see the triangle ABC. Okay. Then we will see the triangle ADE. Okay. Once more. We will see the triangle ABC, then ADE. Now you can say that this side AB, okay, AB is equal to which side? AD. Okay. As you can see this. Okay, this is the symbol of equal sides. So AB is equal to AD. Then AC is equal to AE. These are all given. You can see these highlighters. Then BAD is equal to CAE, which is given, but okay, let's start the proof, then I'll show you what I'm trying to explain over here. Let's check over here. Come on. Now given AB is equal to AD, then put a comma and write AC is equal to AE. Okay. Now angle, this one, BAD. Angle BAD is equal to angle CAE. This is all given. Now, we have to prove the two triangles to be congruent. Then only we can say that BC is equal to, one more line I have to join over here, this one. Yeah. So therefore, we have to prove that BC is equal to DE. Okay, that we'll check out. Now, to prove BC is equal to DE, we start with the proof with the two triangles. In triangles ABC, ABC and triangle ADE, ADE. Now check. AB is equal to AD. Yes, this is given. Learn to write the proofs properly, children, because sometimes this is confusing, but you will learn if you practice it. Then AD. Okay, we have already got AB is equal to AD. Now, we will write AC is equal to AE. AC is equal to AE, which is also given. Now, look at the third part. When I look at the third part, if I say BAD, angle BAD is equal to angle CAE. Yeah? Now, this is not the complete angle, only this is a part of the angle. We actually want this whole angle, if angle A, this one. Okay? Now, as you can see the diagram, what I am trying to explain you is, you pay attention here. Now, this part and this part is equal, given in the question. The center part, which is the part this, when I have to take angle A, okay, when I have to take angle A, then this part will be included in this angle also as well as in this angle also. So what I'll do is, I will add DAC to both the sides. Okay, when I add DAC to both the angles or both the sides, I will then get angle BAC and angle DAE equal, and that will be the third corresponding equal part. So what I am trying to explain you over here, children, see, BAD is equal to CAE, this is given, but this is not the complete part for the congruence. To prove the congruence, what we'll do, we will add DAC to both the sides. Okay, yeah. When I add these two, I will get angle A. And when I add these two, I will get angle A. Now we'll check how. See, BAD plus DAC. Again, BAD plus DAC will be the whole, this angle A. Okay, yes. Now, when I say this part, CAE, okay, CAE plus DAC, this part, this whole thing. Now this is also angle A. For this triangle, this is angle A, and for this triangle also, this is angle A. Okay, so you have to focus on the figure properly, what I'm saying. When I say DAE, we are talking about angle A. When I'm saying BAC, then also I'm talking about angle A. So therefore, in the end, I've got 3 points, 3 corresponding equal parts. This is number 1. AB is equal to AD given. AC is equal to AE also given. And now angle A is equal to angle A. This is the third point. Okay. Now, which congruence rule we are going to apply? By which congruence rule? Check. This side, and angle. That means side over here, and angle. So SAS. The angle is between the two included, between the two sides. The angle is included. So therefore, we'll write by SAS rule, triangles are congruent. Okay, therefore, what do we write in the end? Therefore, BC is equal to DE, and the answer will be what? Reason will be CPCT. So, in the end, we write hence proved. Okay, so did you follow what I've done? First, you take the sides which are already given. Then it is given that these two angles are equal. And for these two angles, to complete these angles, I have to add DAC to both the angles. And then I will get angle A. And therefore, in the end, we write for the third corresponding equal part, we are going to write angle A is equal to angle A. Okay. or we can write BSC is equal to CAE, and therefore the rule SAS we apply here and write that the triangles are congruent by SAS rule, hence BC is equal to DE by CPCT. Now today I have completed 3 questions. Now children, if you didn't understand over here something or any these 2 questions which I have just now completed with you, I mean this is easy, this you can understand. Even here also, if you have any confusion, you can ask me, and yeah, complete your work. And I hope you have started with this chapter, triangles, and like today's Thursday, so I've completed these, and we have how many more questions? Just one more question we have. No, 2 more questions we have in this exercise, which I'll complete with you in the next class. Complete your work. If you have any doubts, children, you can ask me. Okay? Thank you. Have a nice day.